solutions from exercise 4.2 from chapter Quadratic Equations. So in the first question, they've asked us to find the root of the quadratic equations by factorization. Factorization is nothing but splitting the middle term. So in the first question, they've given the quadratic equation x squared minus 3x minus 10. So in order to solve this by splitting of the middle term, we need to find two numbers in which the sum of it will give negative 3 and the product of both the numbers will be negative 10. So two such numbers that I can think of are negative 5 and 2. So negative 5 plus 2 will give us negative 3, and negative 5 times 2 will give us negative 10. So now we're going to substitute these values in the quadratic equation. So we'll get x squared minus 5x plus 2x minus 10, which is equal to 0. Now we're going to take out the common terms. For the first two terms, we can notice that the only common terms are x. So we're going to take out x outside, and inside we'll have x minus 5 remaining. In the second part of this equation, we'll notice that 2 is the common out of both the terms, as 10 is a multiple of 2. So we'll take positive 2 outside, and inside we'll have x minus 5, which is equal to 0. We know that this is right when these two terms inside the brackets are equal. So the two factors of this quadratic equation will be x minus 5 and x plus 2. So x minus 5, which is equal to 0, and x plus 2, which is equal to 0. So finally, we can say that x is equal to 5 and x is equal to negative 2, which are the factors or roots of the first quadratic equation. In the second quadratic equation, they've given 2x squared plus x minus 6 is equal to 0. We need to find two numbers in which the sum equals 1 and the product equals negative 12. Two such numbers can be 4 and negative 3, as 4 times negative 3 will give us negative 12, and 4 minus 3 which will give us 1. So substituting these two numbers in the quadratic equation, we'll get 2x squared plus 4x minus 3x minus 6, which is equal to 0. Taking out the common terms, we'll get 2x outside, and inside we'll have x plus 1. And here we'll take out negative 3 outside, and inside we'll have x plus 1, which is equal to 0. So the two factors of this quadratic equation will be x plus 1, which is equal to 0, and 2x minus 3, which is equal to 0. So x will be equal to negative 1, and x will be equal to positive 3 over 2, which are the factors or roots of the second quadratic equation. In the third question, they've given root 2x squared plus 7x plus 5 root 2 is equal to 0. We need to find two numbers in which the sum equals 7 and the product of the two numbers equal 5 times 2, which is equal to 10. So two such numbers can be 5 and 2. So we're going to substitute these two values in the quadratic equation. We will get root 2x squared plus 2x plus 5x plus 5 root 2, which is equal to 0. In the first part of the equation, we will notice that we can take 2 root 2x outside as a common term, and inside the bracket we'll have x plus root 2, as root 2 times root 2 will give us 2, and in the second part of the equation we can take 5 outside, and inside we'll have x plus root 2, which is equal to 0. So the two factors of this equation will be root 2x plus 5, which is equal to 0, and x plus root 2, which is equal to 0. So x will be equal to negative 5 over root 2, and x will be equal to negative root 2, which are the factors of the third quadratic equation. In the fourth question, they've given that 2x squared minus x plus 1 by 8 is equal to 0. We'll notice that in this question, we have 8 as a denominator. In order to make this much simpler to calculate, we're going to multiply 8 with the numerator and the denominator of both these two terms so that all three terms have the same denominator. And since it is equal to 0, when we bring the denominator from the left-hand side to the right-hand side, it will still equal 0, because any number times 0 will give us 0. So when we multiply 8 with the numerators of these two terms, we will get 16x squared minus 8x plus 1 by 8 is equal to 0. And when 8 comes over to the right-hand side, it'll become 16x squared minus 8x plus 1 is equal to 0. Now we need to find two terms in which the sum equals negative 8 and the product equals 16. So the two numbers in which the sum is negative 8 and the product is 16 would be negative 4 and negative 4. So substituting these two numbers in the quadratic equation, we'll get 16x squared minus 4x plus 1, which is equal to 0. So taking out the common terms in the first part of the equation, we'll notice that the two common terms will be 4x. So if we take 4x outside, the remaining terms inside the bracket will be 4x minus 1. And in the second part of the equation, we'll notice that there are no common terms, so we're going to take negative 1 outside. And inside we'll have positive 4x minus 1. The reason we took negative 1 outside is so that when we multiply it within the brackets, we'll still arrive at the starting point of the equation. So we'll get negative 4x, negative 1 times negative 1 will give us positive 1, which is equal to 0. The two factors of this equation will be 4x minus 1 is equal to 0 and 4x minus 1 is equal to 0. So x is equal to 1 by 4 and x is equal to 1 by 4. Now we'll notice that this quadratic equation has equal roots. When it has equal roots, it means both roots of the quadratic equation are equal. In the fifth question, the given quadratic equation is 100x squared minus 20x plus 1 is equal to 0. We need to find two numbers in which its sum is negative 20 and its product is 100. Two such numbers would be minus 10 and minus 10. So substituting these two terms in the quadratic equation, we'll get 100x squared minus 10x plus 1 is equal to 0. We'll notice that the two common terms that we can take outside would be 10 and x. So when we take 10x outside, we'll have 10x minus 1 remaining. And similarly, in the second part of the equation, there is no common terms. So we're going to take negative 1 outside, and inside the brackets we'll have 10x minus 1, which is equal to 0. The two factors of this equation will be 10x minus 1 is equal to 0, and 10x minus 1 is equal to 0. Similar to the fourth question, the previous question, this quadratic equation also has equal roots, so both of the roots of this quadratic equation will be equal, which is 1 over 10. In the second question, they've asked us to solve the problems given in example 1. So the first question in example 1, they've said that John and Javanti had 45 marbles together. Both of them lost 5 marbles each, and the product of the number of marbles they now have is 124. We would like to find out how many marbles they had to start with. So they've given that the number of marbles John and Javanti had together is 45. And they've also said that both of them lost 5 marbles. And the product of the marbles they have right now is 124. So we're going to assume the number of marbles John had as x and the number of marbles Javanti had as y. Since they've said that the number of marbles John and Javanti had together is 45 marbles, we can say that x plus y is equal to 45. So we need to write the number of marbles Javanti had in terms of the number of marbles John had. So when we bring x to the other side, we can say that the number of marbles Javanti had is 45 minus x. So now we know that both of them lost 5 marbles each. So we can say that when John lost 5 marbles, the number of marbles he now has would be x minus 5 for John. And Javanti also lost 5 marbles, and we know that the number of marbles Javanti had was 45 minus x. So when she lost 5 marbles, it will be 45 minus x minus 5, which is also equal to 40 minus x. So this is equal to the number of marbles they now have. And they've said that the product of the marbles they now have is 124. So basically they've said that x minus 5 times 40 minus x is equal to 124. When we multiply the values inside the bracket, we'll get 40x minus x squared minus 200 plus 5x is equal to 124. So minus x squared plus 45x minus 324 is equal to 0. Since the first term has a negative sign, we're going to multiply it with a negative sign so that it'll be easier for us to calculate. So when we multiply all the terms in this quadratic equation by a negative sign, we'll get x squared minus 45x plus 324, which is equal to 0. Now we're going to find two numbers in which its sum equals negative 45 and its product equals 324. So two such numbers would be negative 36 and negative 9. So substituting these two values in the quadratic equation, we'll get x squared minus 36x minus 9x plus 324, which is equal to 0. Taking the common terms outside, we'll be left with x minus 36, and over here we're taking negative 9 outside, so we'll have x minus 36 is equal to 0. So the two factors would be x is equal to 9 and x is equal to 36. So we're going to take the number of marbles John has as 36. So we can say that John had 36 marbles. And the number of marbles Javanti has is 45 minus x. So Javanti has 45 minus 36 marbles, which is equal to 9. In the second part of the second example, the second question states that a cottage industry produces a certain number of toys in a day. The cost of production of each toy in rupees was found to be 55 minus the number of toys produced in a day. On a particular day, the total cost of production was 750 rupees. We would like to find out the number of toys produced on that day. So we're going to assume that the number of toys produced in a day is x. So they've given that the cost of production of each toy is 55 minus the number of toys produced in a day. So the cost of each toy will be 55 minus x, since we've assumed that the number of toys produced in a day to be x. We know that the cost of production is the cost of a toy times the number of toys produced. And they've already given us that the cost of a toy is 55 minus x. So 55 minus x times x, which is the number of toys produced, will give us the cost of production. And we already know that the cost of production on a particular day was 750 rupees. So the given equation that we can infer from the following points that we were given is that 55 minus x times x equals 750 rupees. So now we have to multiply x with these two values, which will give us 55x minus x squared is equal to 750. So rewriting this in the form of ax squared plus bx plus c, we'll get minus x squared plus 55x minus 750, which is equal to 0. Now we're going to multiply this whole equation with the minus so that the starting term does not begin with the negative value, so that it'll be easier for us to calculate. So when we multiply this whole thing with negative, we'll get x squared minus 55x plus 750, which is equal to 0. Now we need to find two terms in which its sum equals negative 55 and its product is 750. So two such terms that we can take would be negative 25 and negative 30. So substituting these two numbers in the quadratic equation, we will get x squared minus 25x minus 30x plus 750 is equal to 0. Taking the common terms outside, we'll get x times x minus 25 minus 30 times x minus 25 is equal to 0. So the two factors would be x minus 30 is equal to 0 and x minus 25 is equal to 0. So the values of x will be x is equal to 30 and x is equal to 25. So the number of toys produced on that day can be either 25 or 30. In the third question, they've asked us to find two numbers whose sum is 27 and their product is 182. So first we're going to take the two numbers as x and y. So they've said that the sum of those two numbers is 27. So x plus y is equal to 27 and their product xy is equal to 182. Now we need to make sure that a quadratic equation only has one variable, so we're going to write y in the terms of x. So y can be written as 27 minus x. So we're going to substitute this value of y in this in order to find the value of x. So we can write this as x times 27 minus x, which is equal to 182. So when we multiply the value of x inside the bracket, we'll get 27x minus x squared, which is equal to 182, and negative x squared plus 27x minus 182 is equal to 0. We're going to multiply this whole equation with negative, so that we'll get x squared minus 27x plus 182 is equal to 0. We need to find two numbers in which its sum is negative 27 and its product equals 182. Two such numbers would be negative 14 and negative 13. Substituting those values within the quadratic equation, we will get x squared minus 14x minus 13x plus 182, which is equal to 0. Taking the common terms outside, we'll get x times x minus 14 minus 13 times x minus 14 is equal to 0, and the two factors of this quadratic equation will be x is equal to 13 and x is equal to 14. In the fourth question, they're asking us to find two consecutive positive integers whose sum of whose squares is 365. So since they're saying that those two numbers are consecutive integers, we can take those two numbers to be as x and x plus 1. They're saying that the sum of the squares of these two numbers equal 365. So the square of the first term would be x squared, and the square of x plus 1 will be x plus 1 the whole squared, which is equal to 365. So x squared plus 1 plus 2x is equal to 365, as this is in the form a plus b the whole squared, and a plus b the whole squared can be written as a squared plus b squared plus 2ab. So we're going to add x squared plus x squared, which will give us 2x squared plus 2x is equal to 364, as we're bringing positive 1 over to this side, which will become 364. So now we can cancel this by 2, which will give us x squared plus x minus 182, which is equal to 0. Now we need to find two numbers whose sum is 1 and its product is equal to negative 182. Two such numbers would be 14 and negative 13. Substituting these two terms in the quadratic equation, we'll get x squared plus 14x minus 13x minus 182, which is equal to 0. Taking the common values outside, we'll take x outside, so remaining inside the bracket will be x plus 14. And here we'll take negative 13 outside, so we'll have x plus 14 inside the bracket, which is equal to 0. And the two factors of this equation would be negative 14 and positive 13. Since the value of x cannot be negative, as they've said that two consecutive positive integers, so we're going to take 13 as x, and x plus 1 will be 14, so these two are the two consecutive integers. In the fifth question, they've said that the altitude of a right triangle is 7 centimeters less than its base. If the hypotenuse is 13 centimeters, we need to find the other two sides. So they've said that the altitude of a right angle triangle is 7 centimeters less than its base. So we're going to take the base as x, and since they've stated that the altitude of the right triangle is 7 centimeters less than its base, we can write that as x minus 7. In a right angle triangle, we can use the Pythagoras theorem in order to find the other sides, the unknown sides of a right angle triangle. The Pythagoras theorem states that the hypotenuse squared, which is AC squared, is equal to the sum of the squares of both sides, which is AB squared plus BC squared. AC squared is 13 squared, which is 169, and AB squared is x minus 7 the whole squared, and BC squared is x squared. So 169 is equal to x squared minus plus 49 minus 14x plus x squared. Adding the like terms, we'll get x squared plus x squared, which will give us 2x squared, and plus 49 minus 14x. We're going to bring 49 to the left-hand side, so you'll get 120 which is equal to 2x squared minus 14x. Since all of these numbers are a multiple of 2, we can cancel them. So we'll get 60 is equal to x squared minus 7x. And we're going to bring 60 over to this side, so we'll get x squared minus 7x minus 60, which is equal to 0. So we need to find two numbers in which its sum equals negative 7 and its product equals negative 60. So two such numbers would be x squared minus 12x plus 5x minus 60, which is equal to 0. Taking the common values outside, we'll get x minus 12, and we're going to take positive 5 outside, get x minus 12, which is equal to 0. So the two factors, or the roots of the quadratic equation, would be 12 and negative 5. Since the value cannot be negative, we're going to take 12 as the base. So BC is equal to 12. And we know that AB is 12 minus 7. So AB will equal 5. In the sixth question, they've given that a cottage industry produces a certain number of pottery articles in a day. It was observed that on a particular day, that the cost of production of each article in rupees was 3 more than twice the number of articles produced on that day. If the total cost of production on that day was 90 rupees, we need to find the number of articles produced and the cost of each article. So they've given that we need to find the number and cost of each article. So we're going to assume that the number of articles as x. And they've given that on a particular day, the cost of production was 3 more than twice the number of articles produced. And since we've assumed that the number of articles produced is x, we can say that the cost of production would be 3 more than 2x. And they've also given that the total cost of production was 90 rupees. So the total cost of production would be equal to the cost of each article times the total number of articles. We know that the cost of each article was already given, and which would be 3 plus 2x, which is the cost of each article, and the total number of articles we have assumed to be x. So when we multiply both of these two terms, we will get the cost of production, which is equal to 90 rupees. So when we multiply the value of x within the bracket, we'll get 3x plus 2x squared is equal to 90. And rewriting this, we'll get 2x squared plus 3x minus 90 is equal to 0. We need to find two numbers in which its sum equals 3 and its product equals negative 180. Two such numbers would be 2x squared plus 15x minus 12x minus 90, which is equal to 0. So those two numbers are 15 and negative 12. So taking the common terms outside, we're going to take x outside, so we'll have 2x plus 15. And here we're going to take negative 6 outside, and inside we'll have 2x plus 15 is equal to 0. So the two factors of this equation would be x is equal to 6 and x is equal to negative 15 by 2. Since the number of articles cannot be a negative number, we're going to take the value of the number of articles as 6. And we also know that the cost of each article is 3 plus 2x. So we're going to substitute the value of x in this equation. So we'll get 3 plus 6 times 2 is 12. So the cost of each article will be 15 rupees.